this video, we're talking about how to factor the difference of squares. Let's get started. All right, the difference of squares is one thing to look for when you are factoring. Again, there's about 7 different tools that we have to work with when factoring something, okay? One of these is the difference of squares. It's a thing to look for to see if you have, okay? But before you do that, we always start with the GCF. We look for the greatest common factor that divides every term. Frequently, even if you can do the difference of squares, you won't even see it until you already factor out the GCF. Okay, so you always start with the GCF. For every method, you look first for the GCF, and then, you factor out the GCF, if possible. Then, if the polynomial is a binomial, meaning 2 terms, with a square as the first term, a square as the last term, and has a difference between them, meaning a subtraction sign, then we will use this method, which is called the difference of squares. Okay, now one thing to point out, that this may not seem like a big deal right now, but just keep in the back of your mind, there is no sum of squares, okay? X squared plus b squared does not factor anything in the real numbers, okay? And that's important because later on, there is a sum and difference of cubes that we'll talk about in future lessons with future tools, okay? But for binomials, with difference of squares, there's only a difference and not a sum of squares, okay? Now, let me show you first why this even works, okay? If I was given just this, notice if I distribute these, a times a is a squared. A times b is plus ab. Okay, and then this minus b times a gives you a minus ab, and then minus b times positive b is minus b squared. And notice that these middle terms cancel out. Okay, that always happens no matter what a and b are. Okay, so we can look for if we have the difference of squares, something squared minus something squared, that I can look for and notice that I can factor it like this, where whatever was able to be squared to be a squared, that is a, and whatever I could square to become b squared would become b. All right, so I'll give you a few examples of that so you can kind of see what I'm talking about. Let me scroll up. All right, so factor n squared minus 1. Okay, we look, are there GCFs? No, there's no GCFs in n squared and 1, or minus 1. Okay, do we have the difference of squares? Well, is n squared something squared? Sorry, I should write none here. Okay, is n squared something squared? Yeah, okay. Is 1 something squared? Well, yeah, it's 1 squared. So we do have squares and it is a difference. Okay, so what squared is equal to n squared? Well, it's n. Okay, n squared is equal to n squared. Okay, and what squared is equal to 1? Well, it's 1. So I have 1 and I have 1. And then we have minus and plus, and we're done. Okay, so you look for what squares to be the first thing squared, what squares to be the last thing squared. You put those here, bing, 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 bing. One's plus, one's minus, and you're done. Okay, now you can check and multiply that out, and you will get n squared minus 1. Okay, example 2, 4m squared minus 25 isn't as simple as n squared minus 1. Okay, first, is there a GCF? So no, there's no GCF. Okay, now what I think is this something squared? So is 4m squared something squared? And it's sitting on a difference of squares paper, so you notice it right now. But think this through, okay? Is 4m squared something squared? Well, is 4 something squared? Well, yeah, it's 2, right? It's 2 squared is 4. And is m squared something squared? Well, yeah, it's m squared, right? That's positive. I mean, that's looking good. Is 25 something squared? Well, yeah, it's 5 squared, right? So I have the difference of squares. They're both squares, and it's a difference, okay? So I can use the difference of squares, okay? And what I do is I write 2 parentheses for 2 more binomials. The thing that is squared to be 4m squared, which is 2m, goes here and here. Okay? And the thing that's squared to be 25, which is 5, goes here and here. And we do minus and plus. Okay, those different signs create that canceling out of those 2 middle terms. So we only have the first term squared and the last term squared. Okay, let's do one more together. And this is 50x to the 4th minus 18. Okay? So we always start with the GCF. Okay? Is there a GCF? Well, yeah, there is. So 50 and 18 both are divisible by 2. Okay, so I start with the GCF. In fact, if I didn't start with the GCF, I couldn't use the difference of squares because 50x to the 4th and 18 aren't squares. Okay, so I'll first factor out that 2. And this is GCF stuff. So 2 times what is 50x to the 4th? And the answer is 25x to the 4th. Okay, and 2 times what is 18, or negative 18, and it's minus 9. Okay, so I've done the GCF. Okay, now looking at what's inside the parentheses, do I have the difference of squares? Do I have something squared minus something squared? And the answer is yeah, I do. Okay, 25x to the 4th is, let's see here, I still need my 2, the GCF, don't lose that. Okay, I have 5x squared. Okay, that is squared to be 25x to the 4th. Put that twice, 5x squared. Okay, now is 9 something squared? Well, yeah, it's 3 squared. So I have 3 and I have 3. And then is the difference? Yeah, it's the difference of squares. And I have minus and plus, and that is what this factors into. Let me make it so it's in the box completely. That's what this factors into, and we use the tool of the difference of squares. And you can multiply this out, and you would get the original problem. It's a good way to check yourself, okay? But yeah, that's the difference of squares. This video was about the difference of squares. This is one of several tools we have when factoring, especially factoring binomials. Thank you for watching.